Have you ever stopped to think about how close we came to never existing? Right now, over 8 billion humans walk this planet. But there was a moment in our history when our entire species was reduced to just a few thousand people, barely enough to fill a small town. One more disaster, one harsher winter, and the story of humanity would have ended before it truly began. If you've ever wondered what it takes for a species to survive against impossible odds, you're about to find out. And if you enjoy diving deep into these incredible stories of survival and evolution, make sure to hit that like button and subscribe. We've got plenty more mind-blowing content coming your way. The birth of the wise human. Let's rewind about 300,000 years to the sprawling landscapes of Africa. In this ancient world, a remarkable new species emerged from the evolutionary tree, Homo sapiens, meaning wise human. What made our ancestors special wasn't just their physical appearance, though they did look distinctly different from earlier human relatives like Homo erectus or Homo habilis. They had higher foreheads, more delicate facial features, and a cranial capacity that housed something extraordinary, a brain capable of abstract thought. This cognitive leap was revolutionary. While other human species could make tools and communicate, Homo sapiens possessed something more: the ability to imagine, to plan for distant futures, to create complex symbols and share intricate ideas. This wasn't just a minor advantage. It was the foundation that would eventually allow humanity to dominate every corner of the globe. In those early days, our ancestors lived in small nomadic bands scattered across African savannas and forests. Their existence revolved entirely around survival. Men ventured out to hunt swift antelopes, towering giraffes, and even young elephants when opportunity presented itself. Meanwhile, women and children gathered fruits, dug for nutrient-rich roots, and collected wild seeds, a game-changing technology that provided warmth, protection from predators, and a way to cook food. They crafted increasingly sophisticated tools from stone and bone, slowly building the technological foundation that distinguished them from other species. The Great Migration begins between 200,000 and 100,000 years ago. Something remarkable happened. Small groups of Homo sapiens began leaving Africa, crossing harsh deserts and following coastlines into the Middle East. From there, they gradually expanded into Asia and eventually reached every continent on Earth that is habitable. This migration wasn't a lonely journey. As our ancestors spread across the world, they encountered other human species who had left Africa much earlier. In Europe and Western Asia, they met the Neanderthals, stocky, powerful humans adapted to cold climates. In Siberia and parts of Asia, they crossed paths with the mysterious Denisovans. For thousands of years, these different human species not only coexisted but also interbred. Modern genetic research has revealed that most people alive today carry fragments of Neanderthal or Denisovan DNA, a genetic echo of those ancient encounters. Life during this period was brutally difficult. There were no farms, no permanent settlements, no written language to preserve knowledge. Everything centered on immediate survival, finding enough food to eat, locating shelter from the elements, and avoiding the countless predators that viewed humans as prey. Bands typically consisted of just 20 to 50 individuals who moved constantly with the changing seasons, relying on accumulated knowledge passed down through generations and keen observations of natural patterns. Communication was primitive but functional, that allowed coordination during hunts and warned of approaching dangers. Yet even this rudimentary language gave Homo sapiens a tremendous advantage over most other species. For tens of thousands of years, conditions remained relatively stable. The climate was predictable enough that human populations could slowly grow and adapt to diverse environments, from dense tropical jungles to arid grasslands to resource-rich coastlines. Homo sapiens were expanding, adapting, and thriving. They seemed poised for greatness, a small but resilient species brimming with untapped potential. But Earth had other plans. When the sky fell, the Toba catastrophe. Around 74,000 years ago, just as Homo sapiens had begun spreading across the planet in small, scattered groups, nature unleashed one of the most devastating disasters in Earth's recent history. On the island of Sumatra in present-day Indonesia, a massive supervolcano known as Toba exploded with unimaginable fury. To understand the scale of this eruption, forget everything you know about ordinary volcanic eruptions. Toba wasn't just a volcano, it was a supervolcano, a geological monster with destructive power that dwarfs even the most catastrophic eruptions in recorded history. When Toba blew its top, it expelled approximately 2,800 cubic kilometers of magma, ash, and rock into the atmosphere. To put that in perspective, this eruption was roughly 5,000 times more powerful than the 1980 Mount St. Helens eruption in the United States, and far exceeded the famous 1883 Krakatoa disaster that killed tens of thousands. The immediate destruction was total. Within hours, pyroclastic flows, superheated avalanches of gas and molten rock traveling at hundreds of miles per hour, incinerated everything for hundreds of miles around Sumatra. Layers of volcanic ash, several meters thick, buried entire ecosystems across Southeast Asia. Lakes boiled, forests burned, and rivers turned to steam. But the local devastation was just the beginning. Billions of tons of ash and sulfur dioxide were launched into the upper atmosphere, where they spread across the entire planet. Within weeks, this toxic veil had encircled the globe, blocking a significant portion of sunlight from reaching Earth's surface. The result was a phenomenon scientists call volcanic winter. Global temperatures plummeted by 5 to 15 degrees Celsius in many regions. In some areas, the temperature drop was even more severe. Unlike a regular winter that lasts a few months, this volcanic winter persisted for years, possibly even decades. For life on Earth, this was catastrophic. Plants, unable to photosynthesize effectively in the perpetual twilight, died on a massive scale. With the plant kingdom collapsing, herbivores lost their food sources and began to starve. As herbivores disappeared, carnivores followed. The entire food chain, from the smallest insects to the largest mammals, began to unravel. For Homo sapiens, who relied entirely on hunting animals and gathering plants, this was an existential threat, unlike anything they had ever faced. The genetic bottleneck. When humanity almost ended before Toba, Homo sapiens numbered in the hundreds of thousands, spread across Africa and parts of Asia. After Toba, that number dropped dramatically. Small bands were completely wiped out. Thriving communities dwindled to handfuls of survivors. In some regions, humans may have disappeared entirely. This period is what scientists call a genetic bottleneck. A sharp reduction in population that drastically reduces a species' genetic diversity. The evidence for this bottleneck is written into the DNA of every person alive today. When geneticists decoded the human genome, they made a startling discovery. Compared to our closest relatives, chimpanzees and gorillas, humans have remarkably low genetic diversity. Two random humans from opposite sides of the planet are far more genetically similar than two chimpanzees from neighboring troops. This can only happen if our entire species descended from a very small population that went through an extreme population crash. Based on genetic evidence, many scientists estimate that at the peak of this crisis, The global population of Homo sapiens may have fallen to between 2,000 and 10,000 individuals. Think about that. All of humanity reduced to a population that would barely fill a modern sports stadium. We were on the knife's edge of extinction. A single epidemic, one more harsh winter, or another natural disaster could have erased our species from existence forever. The consequences of such a bottleneck are profound. Many rare genetic variants simply disappeared, lost forever as the individuals carrying them perished. The remaining gene pool was dramatically impoverished, making the surviving population more vulnerable to diseases and environmental changes. Some researchers believe that certain genetic disorders common in modern humans, from hemophilia to various immune system problems, may trace their origins back to this period when the human gene pool was reduced to such a tiny, but there's a fascinating paradox here. This near-extinction event actually contributed to human unity because only a few thousand people survived, carrying a shared genetic foundation. All humans today are remarkably similar at the genetic level. Whether you're from Africa, Europe, Asia, or the Americas, your DNA tells the same story. We all descend from that tiny group of survivors who made it through humanity's darkest hour. The secrets of survival, how we made it through. Given that many animal species went extinct during this period, and that other human species like Homo erectus were eventually wiped out, why did Homo sapiens survive? What made us special? The power of cooperation. First and foremost, Homo sapiens understood that survival wasn't an individual achievement, it was a collective one. In those small bands of 20 to 50 people, every member had a role. Men specialized in hunting large game. Women gathered plant foods and small animals. Elders cared for children and passed down knowledge. Young adults defended the group from predators. This division of labor and cooperation was more sophisticated than anything seen in other human species. Archaeological evidence shows that by 100,000 years ago, Homo sapiens were already engaging in behaviors that demonstrated deep social bonds, burying their dead with ceremony and caring for sick or injured group members. This compassion and social cohesion transformed scattered individuals into resilient communities capable of enduring the darkest times. Superior intelligence and technology. Homo sapiens crafted stone tools far more sophisticated than those of earlier human species. They created finely worked spear points, sharp blades from quartz and obsidian. These technologies allowed them to hunt efficiently and process food more effectively. But perhaps the most important technology was one they had mastered thousands of years earlier: fire. With fire, they could cook food, making it safer to eat and easier to digest. Cooking allowed them to extract more calories and nutrients from the same amount of food, providing the energy their large, calorie-hungry brains required. Fire also provided warmth during the endless volcanic winter, kept predators at bay during the night. Coastal refugees. As terrestrial ecosystems collapsed under the volcanic winter, many groups of Homo sapiens did something clever. They moved to the coasts. Archaeological sites like Blombos Cave and Pinnacle Point in South Africa reveal that between 70,000 and 80,000 years ago, humans were extensively exploiting marine resources: fish, shellfish, crabs, and seaweed. This was brilliant adaptive strategy. Marine ecosystems were far less affected by the volcanic winter than terrestrial ones. The ocean retained its heat, currents continued to flow, and seafood remained abundant. These coastal refugees may have been the final sanctuaries where a few thousand Homo sapiens weathered the crisis, slowly rebuilding their numbers over generations. The gift of language. Although not as complex as modern speech, Early Homo sapiens had developed systems of sounds, gestures, and symbols that allowed sophisticated communication. This enabled them to coordinate complex hunts, share information about resources and dangers, and most importantly, pass accumulated knowledge from one generation to the next. This was a capability that even Neanderthals, despite their strength and intelligence, may not have possessed to the same degree. Each generation of Homo sapiens started from a higher baseline than the previous one, building on inherited wisdom rather than starting from scratch. Unmatched adaptability. Finally, Homo sapiens were the most versatile of all human species. They could survive in tropical jungles, arid grasslands, limestone caves, or along windswept coasts. When large game disappeared, they switched to hunting rabbits, birds, and fish. When familiar plants died, they found alternatives, digging up roots, storing nuts, drying fruits. This flexibility set them apart from more specialized species. Many animals depend on specific food sources or habitats. When those disappear, extinction follows. But Homo sapiens could pivot, improvise, and adapt to almost any environment. Our recovery and conquest. Thanks to cooperation, intelligence, technology, coastal resources, language, and adaptability, Homo sapiens passed through history's narrowest gate. From those few thousand survivors, the population gradually recovered. Over thousands of years, humans expanded once again out of Africa, moving into the Middle East, spreading across Asia, reaching Europe, and eventually crossing into the Americas and remote Pacific islands. Along this journey, they encountered other human species, Neanderthals, Denisovans, and others. Sometimes they interbred with them. Other times they competed for resources. Eventually, only Homo sapiens remained. Our survival was never guaranteed. It was the result of intelligence, unity, and extraordinary resilience in the face of catastrophic adversity. Had our ancestors been slightly less adaptable, slightly less cooperative, or slightly less creative, Homo sapiens might have joined the countless species that vanished from Earth, and you and I would simply not exist. The scientific debate. Was Toba really that bad? The Toba catastrophe theory has captivated scientists and the public for decades, but as research has advanced, the debate has intensified. Was Toba truly the extinction level event we thought, or have we overestimated its impact? In the 1990s, genetic evidence seemed to strongly support the bottleneck hypothesis. The unusually low genetic diversity in modern humans pointed to a severe population crash at some point in our past. The timing seemed to match Toba perfectly, creating a compelling narrative. However, starting in the early 2000s, archaeological evidence began to complicate the story. Excavations at sites like Jwalapuram in southern India, an area directly blanketed by Toba's ash, revealed continuous evidence of human habitation before and after the eruption. Stone tools appeared consistently throughout the ash layers, suggesting that local human populations weren't wiped out. Similarly, sites in Africa, particularly coastal caves like Blombos, showed no clear evidence of the catastrophic population collapse that the bottleneck hypothesis predicted. Humans seem to have maintained their presence through the Toba period. Some climatologists have also questioned whether Toba's global impact was as severe as originally thought. While ash definitely spread worldwide, the atmosphere may have recovered more quickly than initial models suggested. Temperature drops may have been regionally variable, with coastal and equatorial areas maintaining relatively stable conditions. There's also an alternative explanation for low human genetic diversity called the founder effect. When small groups of Homo sapiens left Africa to populate the rest of the world, they carried only a subset of the total human gene pool. As these small founding populations spread globally, The resulting genetic homogeneity could explain our low diversity without requiring a global catastrophe. The truth likely lies somewhere in the middle. Toba probably had devastating effects in some regions, wiping out many human groups, while other populations in coastal areas or less affected regions managed to survive. The result was still a significant population decline, enough to leave genetic traces that persist today, but not the apocalyptic near extinction that early theories suggested. What we know for certain is this: Toba did not destroy Homo sapiens. Archaeological evidence shows that humans continued creating sophisticated tools, producing art, and crafting symbolic ornaments throughout this period. If anything, the harsh conditions may have forged Homo sapiens into an even stronger, more innovative species. Modern threats. Could it happen again? More than 70,000 years after Toba, we live in a vastly different world. We have cities, technology, medicine, and accumulated knowledge that our ancestors couldn't imagine. Yet Earth still harbors threats that could push humanity into another bottleneck. Or worse, supervolcanoes still exist. Yellowstone in the United States sits atop a massive magma chamber. An eruption even a fraction of Toba's size would collapse global agriculture, potentially leaving billions facing starvation. Climate change presents a different kind of threat, slower than a volcanic eruption but potentially just as devastating. Rising temperatures, melting ice sheets, rising sea levels, and increasingly extreme weather could trigger famines, mass migrations, and conflicts that destabilize civilization. Nuclear war remains a terrifying possibility. A large-scale nuclear exchange wouldn't just kill hundreds of millions directly. It would create a nuclear winter similar to Toba's volcanic winter, spreading radioactive fallout and destroying crops across vast regions. Global pandemics are another concern. In our interconnected world, a highly lethal and contagious pathogen could spread faster than anything in human history. COVID-19 gave us a glimpse of how vulnerable we remain to microscopic threats. And finally, threats from space, asteroids, and comets constantly orbit through our cosmic neighborhood. One large enough impact could trigger an extinction event, just as one did for the dinosaurs 66 million years ago. The critical difference between then and now is that our ancestors survived through cooperation, adaptability, and their wits alone. We have those same qualities, plus advanced technology and scientific knowledge. Technology can be our shield, or, if misused, it could become the very thing that destroys us. The lesson of the bottleneck. The story of humanity's near extinction carries profound implications for our present and future. It reminds us that our existence has always been fragile, that we've survived not through inevitability, but through resilience, cooperation, and adaptability. The genetic bottleneck also reveals something beautiful. Beneath our surface differences in language, culture, and appearance, all humans share a fundamental kinship. We are, quite literally, one family descended from a small group of survivors who refused to give up when the world turned against them. As we face the challenges of the 21st century, climate change, technological disruption, geopolitical tensions, the story of Toba offers both warning and hope. It warns us that catastrophe can strike suddenly and that no species, no matter how successful, is guaranteed survival. But it also demonstrates humanity's extraordinary capacity to endure, adapt, and ultimately thrive in the face of seemingly impossible odds. Just as 74,000 years ago, our future depends on the same qualities that saved our ancestors: cooperation across boundaries, intelligence applied wisely, and the flexibility to adapt to rapidly changing circumstances. Will we use our technology and knowledge to navigate the threats ahead, or will we create our own downfall? The answer is being written right now, in every choice we make as individuals and as a species. The story of humanity's bottleneck isn't just ancient history. It's a mirror showing us what we're capable of surviving and a reminder of what we could lose if we forget the lessons our ancestors learned on the edge of extinction. One thing is certain: the same qualities that carried a few thousand survivors through Earth's darkest hour still live within us. The question is whether we'll choose to use them.